The ArrayList object is mutable and contains object references. And we'll draw similarities between ArrayLists and arrays as we progress. So what we do is first import ArrayList from the java.util package. And we use the ArrayList constructor of the ArrayList class to create an empty list. So I'm going to call this an ArrayList of numbers. And that's equal to new ArrayList. So to draw analogies between the ArrayList and the array of numbers, let's add some numbers to the ArrayList. So we use the add method. And this add method takes in objects. So if I add a number to the list, it basically converts this to an object. And now let's add the remaining numbers. So we have 1, 14, 7, and 5. So the ArrayList is dynamically sized, whereas the size of an array cannot be changed. And now if I print out this list, that automatically invokes the .toString method of the ArrayList class. So if we run the program, we see that this list of numbers is printed, which matches those in our array. Now the ArrayList is different to an array because we can store objects in the list that are of a different type. So for example, if I replace 14 with a string, so I'll just call that word, then that's allowed, as we can see. Now this is not good coding practice, and we can demonstrate this by, for example, declaring an int called num, and I'm going to set that equal to the first number in this list. So we have al numbers, and we use the get method to access the first number at index 0. So note that the regular array starts from index 0 and ends at the number of elements minus 1. And here we need to cast the object to an integer. And now I'm going to print out that number. So as we can see, we get 12. Now if I want to access the third element in the list, being the string, then that's going to cause a runtime error, because a string cannot be cast to an integer. So it's bad coding practice to add objects with a different type. So for this reason, Java allows a generic type. So this is ArrayList E, where the generic type E specifies the type of the elements. So to do that, for example, I'm going to specify an array list of integers. So as we can see, we can no longer add a string to the list, which is a type safety check, as we'll get a compile error. So we'll change this back to 14. So when we write 14, the compiler is basically doing auto boxing, which is converting this int to an integer object. So it's the same thing as saying new integer, which gives the same result. And note that the integer constructor has been deprecated. So effectively the correct way is to write integer.value of. And that also gives the same result. So when ArrayList E is specified, the types of the reference parameters and return type, when using the methods, are of type E. So essentially we don't need to cast to an integer anymore. So when we get the element at index 2, we again get 14. And at index 3, we get 7. So ArrayList with a type E is preferred over ArrayList because it allows the compiler to find errors that would otherwise be found at runtime, as we've seen.